Okay. Okay. What we are doing, the first statistical test, because what you just did on that last problem set was someone gave you the calculated test statistic and you just compared it to a table value. So now we're going to start with you actually calculating your own test statistic. And the first one we're going to do is a t-test. And what a t-test does is it compares means. So you have two lists of data, like your paper airplanes. You did your paper airplane lab. You had two sets of data. Oh, the average distance that it flew when I put a paper clip on it was bigger than when there wasn't. What a t-test does is it looks at you're still on the green sheet. Yeah. What it's doing is it's comparing the means and is the difference significant? Okay? So you need your calculator. Okay. On your calculator, I want you to hit stat. Actually, oh, okay, that one does lower. All right, I want you to hit stat. Okay? And now you're used to edit, but I want you to do tests. Okay, and you see your tests and you have a lot of them. Okay, what we are going to do is number 4. Which is a 2-sample t-test. Okay, now do you see where it says input? Apparently my calculator is now possessed. Okay, so under there, do you see how it says data or it says stats? Like I said, mine is possessed. Okay, you can choose from data and stats. When you have data, it uses lists. So it uses, if you have entered your data into list 1 and list 2, stats is like your data lists are elsewhere, and you have the mean and the standard deviation, and you're just going to enter that. It would be really good to use the stats if you have lots of data in Excel and you don't want to transfer the data to the calculator. You don't have the TI Connect software. Excel will give you a mean. Excel will give you a standard deviation. It gives you your number of items, but unless you have the statistics add-in, you can't do the t-test in Excel. Okay, so look at the green sheet, look at practice set 3. Okay? Number 1, it's got 2 lists. What it gives you is the mean, the standard deviation, and the number. So are you going to use data or stats? You're going to use stats. But before you enter into the calculator, you need your hypothesis. Okay? So, what's the null? Mu 8 a.m., mu 12 p.m. What do we put in between them for the null? Equals. Okay? Now, the one we need for the calculator is we need the HA. So, what is her hypothesis? The morning one would be more effective. So, what would we put in? The 8 a.m. is greater than. Okay? Oops. That's not my calculator. That's my calculator. All right. So, let's see if my calculator will cooperate. Has not been so far, so let's try it again. Okay. So, go over to stats and hit enter. So your screen changes so you can enter stats. Okay? X with a line over it is the mean. So what is the mean from 8 a.m.? 70.8. Okay? The SX is what the calculator uses for standard deviation. So what is the standard deviation? 30.8. Okay, what is the number of items? 30. Okay. For the second set of data, what is the mean? 77.4. And the standard deviation? 31.2. And does it also have 30? Okay. Now, do you see the next line? You can test mu1 not equal to mu2. That's your two-tailed test. Or you can choose mu1 greater than mu2 or mu1 less than mu2. Which one do we have? Greater than. So we have to go over and highlight that. We always leave our data as not pooled, and then we calculate. Okay? So our test value is 0.8245. And our P was 0.79. No, you don't need to worry about if it's negative. So our alpha was 0.05. Look on the table to see what your test statistic is. We have an alpha level of 0.05 and how many degrees of freedom? Well, we have 30 plants in each group. So 30 minus 1 is 29, plus 30 minus 1 for the other one. So we have 58 degrees of freedom. So you just go to 60 on the chart because it doesn't have 58. So 1.671 is our critical table value. So what do we reject? What do we do with our null hypothesis? Do we reject or fail to reject the null? We fail to reject HO because our t-value of 0.8245 is less than our critical table value of 1.671, and our p of 0.79 is greater than our alpha of 0.05. We fail to reject the null if the p-value is greater than the alpha, because p is our probability of error. So the probability of error is 79 out of 100. Is this happening because of our experiments? Probably not.
Is t negative?
It did come out negative, but we need to just look at the absolute value of it for comparison. Now, another way you can look at it on the calculator. Hit Stat and go to Tests again. Go down to that same test. Leave all of your data there, all of the stuff you entered, but go down this time and instead of calculate, draw. I got an error. Okay. Did you get, when you drew it, you got this? And it's pretty much all colored in? Yeah. Yeah, okay. Okay. When you draw, it's colored in kind of like that. I don't know, because mine's giving me an error too. Probably. Okay, when you have a shaded graph, you fail to reject your null.